All right, we want to talk about data now. So, data is a big choice, and here is the scenario. We have this guy, Jason, a serious developer, but he has to choose a back end, and he wants to use the cloud because he doesn't want to maintain services with SQL Server or whatever in his organization. He's going to make a modern solution. He wants whatever he's done, like it's being produced in Australia, he's going to sell this product in Australia. Later on, if it does well, he wants to sell it in the US, obviously, okay? But he wants to handle plenty of data when he needs to. He wants it to be near real time. He's got lots of choices. He can go with relational. SQL is pretty common. There's MySQL. There was a fork called MariaDB. I think that originated because people were annoyed about Oracle buying MySQL, and so they created a fork. I've heard many good things about MariaDB. There's PostgreSQL. There's non-relational solutions. Cosmos is one. There's storage. There's plenty of data analytics stories he can think of too. But the simplest thing to get it up and running, can you take a vote? Let's just say you could choose SQL or Cosmos. I guess that would be the main ones. Who would choose SQL for Jason? And I think I have 90% of the room. Who would choose Cosmos? Nope? Okay, cool. So we got 90% of the room would choose SQL and 10% would choose no database at all. That be right? Callum, what did you choose?
I'll go Cosmos.
You go Cosmos. Oh, right. Okay, cool. You're really modern. Okay, so let's talk about this a bit more because this choice is not easy to change later. I'm going to play a little video just quickly. All right.
Oh, we need sound.
Right, do we have sound?
You use MongoDB.
MongoDB
MongoDB is a web-scale database and doesn't use SQL or joins, so it's high performance.
That's an excellent question. We evaluated several NoSQL databases and concluded that the options are still too immature for our production needs. MySQL is a proven database that is used across the web and it has the features we need.
But it doesn't scale. Everybody knows that relational databases don't scale because they use joins and write to disk.
Scalability is a complicated topic and it's hard to make a general statement like that.
Relational databases weren't built for web scale. MongoDB handles web scale. You turn it on and it scales right up.
It may surprise you that there are a handful of high-profile websites still using relational databases and in particular MySQL.
Relational databases have impedance mismatch.
I think you mean impedance.
MySQL is slow as a dog. MongoDB will run circles around MySQL because MongoDB is web scale.
MongoDB does have some impressive benchmarks, but they do some interesting things to get those numbers. For example, when you write to MongoDB, you don't actually write anything. You stage your data to be written at a later time. If there's a problem writing your data, you're fucked. Does that sound like a good design to you?
If that's what they need to do to get those kick-ass benchmarks, then it's a great design.
If you are stupid enough to totally ignore durability just to get benchmarks, I suggest you pipe your data to DevNull. It will be very fast.
If DevNull is fast in web scale, I will use it. Is it web scale?
You are kidding me, right? I was making a joke. I mean, if you're happy writing to a database that doesn't give you any idea that your data is actually written, just because you want high-performance numbers, why not write to DevNull?
It's fast as hell.
Oh no, we're going to, we'll do it that way. Okay, I'll play this video, Raj, and then we'll go back and start that again, okay? All right.
Holy shit, we have fun.
Okay, I play this video because I've been in a lot of meetings, and you're in a meeting with serious dudes, okay? We have some serious dudes here that don't like these type of conversations. They've been using SQL Server for their entire life. And the young web developers, especially all the guys that come out of university these days, they all know Mongo quite well. Or document database, Cosmos, those type of document databases. They actually don't know SQL. We actually put it in our employment test to make sure they do know SQL, because they're great coders but don't know anything about databases. And then you've got the old guys who just just don't like this stuff. Anyway, this is not dissimilar to many conversations I've been in, and some of the conversations end up with the guys not wanting to talk to each other for days.
In conclusion, we have found MySQL to be an excellent database for our website. Any questions?
Yes, I have a question. Why didn't you use MongoDB? MongoDB is a web-scale database and doesn't use SQL or joins, so it's high performance.
That's an excellent question. We evaluated several NoSQL databases and concluded that the options are still too immature for our production needs. MySQL is a proven database that is used across the web and it has the features we need.
But it doesn't scale. Everybody knows that relational databases don't scale because they use joins and write to disk.
Scalability is a complicated topic and it's hard to make a general statement like that.
Relational databases weren't built for web scale. MongoDB handles web scale. You turn it on and it scales right up.
It may surprise you that there are a handful of high-profile websites still using relational databases and in particular MySQL.
Relational databases have impedance mismatch.
I think you mean impedance.
MySQL is slow as a dog. MongoDB will run circles around MySQL because MongoDB is web scale.
MongoDB does have some impressive benchmarks, but they do some interesting things to get those numbers. For example, when you write to MongoDB, you don't actually write anything. You stage your data to be written at a later time. If there's a problem writing your data, you're fucked. Does it sound like a good design to you?
If that's what they need to do to get those kick-ass benchmarks, then it's a great design.
Right.
If you were stupid enough to totally ignore durability just to get benchmarks, I suggest you pipe your data to DevNull. It will be very fast.
If DevNull is fast in web scale, I will use it. Is it web scale?
You are kidding me, right? I was making a joke. I mean, if you're happy writing to a database that doesn't give you any idea that your data is actually written, just because you want high performance numbers, why not write to DevNull? It's fast as hell.
Does DevNull support sharding?
Holy shit. For my own mental health, I'm going to assume you're just messing with me and aren't actually retarded. Do you even know what a shard is?
Shards are the secret ingredient in the web scale sauce. They just work.
Please tell me you don't actually make a living in a technology field.
I'm a web programmer.
As of this moment, I officially resigned from my job as software engineer and will take up work on a farm shoveling pig shit and administering anal suppositories to sick horses because that will be 1,000 times more tolerable than being in the same industry as dipshits like you. You read the latest post on highscalability.com and think you're a fucking Google architect. There's slogans like web scale and sharding, but you have no idea what the fuck you were talking about. You're going to blow some project to hell because you get a Woody playing with software like it's a sex doll. Relational databases have been around since the fucking 70s and are some of the most mature technology you can find. Yet somehow everything needs to be reinvented because Google and Amazon post some white papers. If you need to build a globally distributed search engine that manages petabytes of data, fine, build your own database. But if you're like 99.9% of companies, you can probably get by very well with something like MySQL and maybe Memcache.
Redis will kick Memcache's ass. It's so fast and scalable.
Right now I'm thinking of how much fun it will be to castrate my first bull down on the farm. I cannot wait to cut off the testicles of a 3,000-pound raging bull as it tries to kick my head in.
MongoDB is a document database that doesn't need joins. It uses MapReduce.
Now I'm cleaning a cistern of chicken shit, but I don't care because I don't have to listen to the NoSQL fanboys reciting the feature list of their favorite schema-free database.
By writing to memory mapped files, MongoDB can improve its output by a factor of 10.
What the fuck? Let's abandon transactions, consistency, durability, and pin our mission-critical data to a table and give it a night it will never forget. I mean, who cares what we store as long as we do it quickly? Oh, sorry. That's right. I'm on the farm now suffocating from the stench of 1,000 cow farts. But it smells like roses to me, because I am nowhere near this moronic conversation.
MongoDB uses atomic modifiers for contention-free performance.
Now I've contracted hemorrhagic E. coli from cleaning cow stalls and I'm bleeding out my asshole. I'll be dead soon, but that is a welcome relief. I will never have to witness the collapse of the world economy because no SQL radicals talked financial institutions into abandoning perfectly good data stores because they didn't support distributed fucking MapReduce.
MongoDB stores files of any size without complicating your stack.
Thank you for your questions. This presentation is over and I'm fucking off to the farm to start my new career.
All right. Now you want to know something? CosmosDB has heaps of financial institutions now running it. Almost all the new projects are using, CosmosDB or MongoDB. It's definitely the way forward. However, in enterprises, there's a lot of guys like that. In our company, we're a little company, we have many guys like that. They will not entertain anything that doesn't support ACID, that doesn't have, they give a lot of reasons. So, Raj, I'm going to kick it off again, okay? Okay. So we're going to talk, Raj? Okay, we're going to talk data, and we want a solution that's accessed globally, near real time. We've got options like SQL and a series of other ones, and we've also got other options such as Cosmos. And there's a lot of choices here. What should Jason choose? Should he choose SQL or Cosmos? Now, they're the two. Now, there is a video here that you can watch later, which is just tells you a comical story about a young programmer and an old dog that doesn't want to learn new tricks. It is this guy. Do I have it? No,
you
closed it. Okay. But here are the conversations you will have with enterprises. You will say, look, it's not a choice. The database that we have in our organization is older than every app, and that's what we're going to continue using. You've got that SQL Server or nothing. Okay, that's fair enough, that happens. Mm-hmm. They will also tell you that, that's what we're used to, that's what you should choose. We have DBAs in our company that can help you. We've got no one that will help you with any problem with Cosmos, a fair point as well. Our domain is highly relational, okay? And that can be true as well. And other ones where they want transactions, but the bottom line is, it is very hard to scale out. Let's just say that Jason has it all up and running in Australia, and then on Friday, the boss comes to him and goes, are you all right for Monday, the New York release? We've been advertising for ages. And Jason goes, no, I'm not ready. I can't just make it fast in New York. It's not going to be, it's not ready. They're going to be using Australia. There's going to be a lag, and there's definitely seconds in that. I can't do anything about that. And he goes, no, you have to make this. We spent a lot of money on this marketing campaign. It's all to New Yorkers. It's got to be fast. And so all Jason could do is try to spend the entire weekend learning SQL Server, transactional replication, or merge replication, or however he wants to do it. He won't know this stuff. It will be hard. How many people here have dealt with replication before? Oh, so there's hardly any experience in the room. It is not fun. We've dealt with it a lot, and you can kind of get it working, and then you always end up having troubles. With Cosmos, if you chose Cosmos, you go into Azure, Cosmos, and you basically check a box that says make it run fast in USA East, and you're done.
Easy.
And under the covers, a copy of the database happens there, and then you choose between a series of settings how fast it is going to be. Okay, consistency alternatives. We'll talk about that shortly. So the non-relational kind of progressive ones, and this is not for every solution, don't get me wrong, but it's definitely something you should be considering. It's much faster for development. There's less mapping of your C# to persistence. It's web scale, as that video talks about. There are some other things, such as backups that are done differently, can give old DBAs pain. Reporting. It's not the world's best thing for doing reporting services reports on, or Power BI. You will, what you typically do is you have that feeding into a relational database, and you do all your queries on that, and that might be, hours old, or minutes old, or seconds old, or even less if you want to pay for it. Okay. Prem, what was your question, sir?
Just on the just going back a little bit, you mentioned about the things running in New York. Does it make that big a difference for if you don't have a database in New York for the New York customers? I mean, how much of a difference is it if they try to access the stuff in Australia, for example?
Oh, we're talking not very much difference, but if you really want, like, if you're a big organisation and your whole thing is it's got to be fast. I can tell you, having been in China for a few months, it is critically important. If you want a site to be like, we can access everything in Australia from China. It's a real lag, You want it to be fast there. If you're trying to sell stuff to, the German market, you're crazy not to have it lightning fast for them. But that's a business decision. I'm not saying it won't work, but it'll be noticeable. It's not a local site. Yeah. So, Will, what do you want to say?
Well, just more considerations as a developer to consider something like CosmosDB. You can use an ORM, so like EF Core. That really makes it easy to map your relational data to an object-oriented abstraction. It's fast to develop your new solution. The ORMs are really great these days, but they do sometimes generate suboptimal queries. So it works great to get you up and running. You can write your code, insert records to the database and pull it back. But sometimes they're not the greatest commands to run, the queries to run. So you always need to measure your performance and adapt your code.
Has anyone actually gone into the SQL that Entity Framework emits and tried to analyze what's in there? Anyone done that? Yeah. It can generate quite a bit of SQL that was never meant for a human to read.
Yeah, noisy SQL. So if you do experience this, it certainly has an impact on the patterns that people use these days for large enterprise applications. A couple of these are event sourcing and CQRS. Has anyone in the room used these patterns before? Okay, not yet. So they are highly optimized solutions for sending a lot of data between your applications and making it available to your users really quickly. The idea is you have to write your code, or your implementation is very specific to your domain. There's a lot of design that goes into setting up an event source and CQRS pattern. So it all comes down to trying to deal with eventual consistency. So from the video that we watched earlier, they mentioned that you write your data, but it's not actually written, it's staged to be written. So what this means is you create a new item in your database, but you don't get an ID back just yet. And if you read to the database, you might not find it straight away. It'll become available in a moment, but not instantly. So eventual consistency lets you write really quickly, but your reads will be a little bit delayed. But the good thing with CQRS and event sourcing is that you can separate your persistency technologies, so you can actually mix Cosmos and SQL together. And in a CQRS model, oops, wrong button. You can consider your commands as the commands that will have a side effect to your database when you're writing records or updating records in your database. And writes are slow, whereas queries, they should be nice and quick. So what you could do is you could write to a CosmosDB, because it can write really quickly. You can store a lot of information in there. And it's got a feature it's called change feed. So as soon as anything changes in your database, it can trigger an Azure function. And from that Azure function, you'll know what changed in your database. And then you can transform that into something that is easy to read and quick to read from even SQL. It could also be Cosmos itself. But it gives you the options to react to changes in your database and save it separately. So, yes, Adam.
Yes. So your ORM, typically at SSW, we use Entity Framework.
That's right.
The event sourcing CQRS solution, what do you use for that?
We usually use Mediator to take care of the CQRS pattern.
Right.
With event sourcing, it's usually something we try and implement ourselves. There's not many good frameworks out there that aren't overkill. Some of them are really huge and hard to use. I've generally just implemented my own. You can use things like Event Hub or Event Grid to publish messages at a high speed and at a high volume.
So are you saying that you stop using Entity Framework and you start using Mediator?
No, I actually use them together, but you also have the option of not using any ORM at all as well. So what I was going to get to is when you have...
With SQL or with Cosmos?
Oh, so with Cosmos, you also have the option of using an ORM like EF Core, or you can use Cosmos directly. So when you have the case of noticing that some of the queries generated by your ORM is suboptimal, with the CQRS pattern, when you're trying to do a query, like a really quick query, you can use raw SQL or the raw Cosmos API to get around these suboptimal queries. So you can handcraft it, because a read or a query is read-only. So there shouldn't be any side effect to your database. You'd use the ORM for the commands instead, because it takes care of all the constraints and the relationships of a database. So that makes it easy to develop. Whereas a query you want to have really quickly, you can generate the best query possible. So, and yeah, this CQRS just lets you mix whatever persistency technology you need. But a lot of work goes into this setting up this pattern and event sourcing. So once you make that choice of going down using CosmosDB, it's hard to then change that architecture to SQL. That's why you have to consider all these things before choosing one or the other. But the ORMs and packages like Mediator makes your life just a little bit easier.
And if you were choosing a database for a web, all right, let's just do a normal one, say a Northwind application.
Yeah.
You know, tables, orders, etc. What would you choose?
I think I'll still choose CosmosDB.
Really?
Yeah.
You wouldn't
So
go
for me,
with SQL for something fairly relational?
If the data is highly relational, yes, then I would choose SQL. But most of the time, you could still get away with using a document store. You can store whole objects. So if you have an item, you can store all the orders in that item. It'll just be like an array or a list of items with, an array of orders for that item. So you can still include sub-objects in an object. That's what CosmosDB is really good at. So you can still have relationships, but not as strict as you have them with SQL, for instance.
So I know the answer to the next question. If you did like a website taking orders and stuff that was definitely not an internal app, you would definitely go Cosmos.
I'd still definitely go Cosmos. Cosmos does support pretty much everything that SQL Server does. It uses various APIs, and one of them is a SQL-like API. We'll cover that, I think, very shortly. So my choice definitely is CosmosDB for most situations.
Awesome. So today, this is how people think about it. A lot of the architecture is when you get a document, you might have an order with products in it and different pieces of data. You just save whatever they entered and you save it as you got it. You don't split it up into, well, say a bit into this table, a bit into these tables, etc. So you save it. You always try to consume less resources, and you don't want websites to wait at all. Just save it as we got it in a JSON file. The reporting, you take a second or so later, and that goes into a reporting services, so into a reporting database where you do all your Power BI or whatever. And today, you never need to learn SQL replication with the solutions. Like that's almost now an answer for a problem that doesn't exist. So, I have a question for you guys. What solution do you think Jason should use for this Northwind 365 website? Who would choose SQL? Okay, we've got a few, got a quarter.
Yeah.
And who would choose Cosmos?
I convinced them.
Wow, that's a big turnaround. So we went from 90% choosing SQL to probably 75% choosing Cosmos. Yeah, huge turnaround. Awesome.
So this all may be cool for new projects, but for the legacy projects, like we have legacy projects which has like 1,000 lines of a query, joins this, join that. Even the person who has written it doesn't know what it does. So how can we like change it all of a sudden?
So Raji, I don't want you to go back tomorrow and say, hey, I came to the Azure Superpowers in Sydney and I think we should change our databases to Cosmos. That's not what I'm trying to get across. I wouldn't even say for your next enormous project, straight away choose Cosmos. I would say for sure evaluate it, but for your next project that's small, I would definitely tell you to choose Cosmos so that you get used to how it works and you see how it works and there's many small differences. Your coding might be much different. You probably won't even notice it on a day-to-day basis. It's just the configuration that you will, you'll also be more aware of the costing is done differently. So yeah, that's my main thing. My main point is, when we go to companies and talk databases, most of the people in charge are definitely over 40 in charge of databases. They're the serious dudes with experience. They won't have the conversation. They won't even let you breathe talking a document database. They've had it too many times and we're not talking. And when I've been in meetings and two people are there and I'm just an arbitrator not even involved, they're angry at me afterwards and I'm not even involved. I'm just listening, So it's definitely a passionate topic. So I'm going to tell Jason to use CosmosDB. And it provides the best. It's the only one for SLAs, high availability, high throughput, low latency, and tunable data consistency. If you look here at their site, you will see you've basically got to choose between strong and eventual. Okay, eventual is much cheaper. It's the way that the writes are written and when you start seeing them and in which order. Okay, so you might, some database guys definitely want a write written and read, written and they want to see it in the same order. Other people don't care, okay? A good example is Twitter. Twitter wouldn't care whether, the number of followers, whether that order is correct. All we care is when you go to your page and you click on followers, it eventually updates. It doesn't matter if it updates before the other person got the followers before. It's just as long as the data shows. So depending on your configuration will depend on what consistency level you choose. But you've got to learn between strong, bounded, session, consistent, or eventual, okay? And they've even, obviously this must be made for Americans, but they've explained this through baseball, okay? But this is this is the type of stuff you'd learn with Cosmos, okay? And then the pricing. All right, so anyway, let's just assume we've chosen this for our next project. Let's go ahead and do it. What's involved here, sir? We would then need to worry about what API Jason is going to use. He might choose the SQL one or the Mongo one or the Graph one or Table or Cassandra. Which one would you use?
I would choose the SQL API.
Right. And I should tell you, when you look at this site, and there's a video here, they now call it planet scale, not web scale anymore. All right, cool. And these are the different ones. There's the SQL API. the .NET guys can use any of these guys. What I should tell you also is coming in .NET 3, .NET Core 3, we will find that there is an Entity Framework API, which is a provider for SQL.
So there's already a provider for SQL, but EF Core will have a provider for CosmosDB, and it's pretty much going to be a one-line change to use CosmosDB versus SQL. For the other providers, might be more work to migrate and change, but very nice and easy for CosmosDB, because CosmosDB's SQL API supports most of what normal SQL supports. So you could get an enormous benefit, the little planet scale database features by using the new provider. It is currently in preview, so use at your own risk, but in .NET Core 3 they've promised it'll be out for general release.
Okay. So getting started is pretty easy if the coding doesn't change. There's a couple of situations where you should only use CosmosDB. If you're getting huge amounts of data, like you've got IoT devices everywhere and they're flooding, we've got many manufacturing style customers that could only really, it's not designed for SQL. If you want the ability to light up a data center in another city with no work, and that that's going to happen, you definitely should be using Cosmos. And then you just replicate the non-SQL data over there. So I think we will take a break right here, and we'll come back, and then we'll go ahead and walk through doing it.
Very cool, thank you.